In this video, we're going to take a look at a problem known as the max subarray sum problem. The idea is that you're given an array of numbers, and your goal is to try to find the subarray within the main array of numbers that, when the numbers are summed, gives us the largest possible sum. So if you were to take a look at, for instance, an example that looked something like this maybe, right? There are a number of different subarrays that we could possibly pick. When we take a look at this, it seems like 5, 3, 4, 1 would probably give us the maximum sum. And this probably becomes even more clear if I made this like a negative number, right? Then pretty clearly this would be the largest possible subarray sum that we could possibly make, right? Anything else that we were to put inside of here would end up being smaller. There's less numbers that are summed up, and really these are just subarrays of the main big subarray that I put in. So we can see that the sums will end up smaller each time unless we pick the whole 4 numbers here. So that'd be an example of one way that we could take a look at this problem. Now the solution for this problem is actually a very famous kind of algorithm. It's called Kadane's algorithm. And the idea of this algorithm is basically that it's a very similar approach to dynamic programming and is usually considered around the realm of dynamic programming. It's going to keep track of a few different pieces of information as it iterates through the array, and it's going to use that in order to construct that maximum subarray that could be summed to the largest possible value. So let's take a look at what this algorithm actually looks like. We'll describe that as we go, right? So let's say max subarray sum. We're going to take in an array as our argument. And what I'm going to do is I'm going to start by setting my result, so the largest possible sum that I can get. I'm going to start it as the first element in the array. I'm then going to keep track of the maximum ending. So where the ending of my largest subarray is. We're going to start that at an array of 0 as well. And what we're going to say is we're going to say as we iterate through the whole array, if we go from 1 to the length of the array itself, we are going to set the max ending to be equal to the following. The maximum of either the max ending plus the value at I, or just simply the value at I. So essentially we're going to keep track of which of those ends up being bigger. Is it larger to add this value to the current max ending, or is it bigger to just start at a new location itself? Then similarly, we can calculate the result in the same sort of way, right? We could take in the max of the result and max ending and determine which one ends up being larger. And then at the end, we simply just return back the results and we're done. You'll see that this ends up being a little bit of a different approach from the dynamic programming problems that we've seen so far. In most of the dynamic programming problems, we have a large table of values that we're keeping track of and we put it inside of an array. In this example here, we're actually only really keeping track of a small set of values, that being the current ending of the subarray that we're summing up, as well as the largest sum that we've seen inside of that subarray. By keeping track of those two pieces of information on each iteration, we can use that previous information in order to determine what our next step should be. So, if we take a look at an example again, right? So we could go back to a similar example to before. And generally, just to give you a bit more intuition around how this is working, right? Basically, with a sum, there's like two different ways that we can, two different situations that we can really get into, right? One where we increase in value, one where we decrease in value, right? If I add two positive numbers, I increase in value. But if I add on a negative number, I'll end up decreasing in value. So basically what ends up happening here is when we compare it, we just need to see if we're increasing or decreasing. Once we hit a point where we start to decrease, then we move on to look at a new subarray. In doing that, we'll actually end up with the maximal subarray on each time, right? So let's take a look at this example one here and just verify that it actually ends up working, right? You see that the maximum in this case is 12. So basically the way that we got here is we do 1 plus 5, which is 6, 4, which is 10, 12, right? Once we get here, we would end up as 10, which would be smaller. So that wouldn't actually be a solution. And you can see basically no matter what ends up happening, this ends up being the maximum. Right? Just consider, for instance, if we were to start at 5 instead. Well, we would only be able to get through 3 elements until we reach here. That's always going to be smaller than if we started at the beginning, right? Similarly, if we start at -2, we might be able to get a larger one if the next numbers that precede are larger. So that's why we're able to do this piece here. Basically, we keep going until we reach something that makes it smaller, and then we start again and keep going until we reach something smaller, right? Because of the fact that as we go through the summing, we're either increasing or decreasing, there's never going to be a larger subarray within a subarray, so that gives us this optimal solution here. Generally, this solution, of course, is O of n. We only iterate through the whole array once, so that gives us a nice, efficient solution to our max subarray sum problem. So thanks so much for watching this video, and I'll see you in the next one.